Okay, we're given some information that we have a population mean, which is my mu, of 800, my standard deviation, my sigma, 200, and a sample size of 400. And so it says this is selected, and my sample mean is used to estimate my population mean. What is the probability that the sample mean will be within plus or minus 5 of the population mean? Well, plus or minus 5 would mean I would have a, let's call it lower x and an upper x. So minus 5 and then plus 5. So those are my two x values that I'm going to find these probabilities. So the only thing, and you can do this either in one formula, but a lot of times they might ask you separately, what's the standard error? And how you find that is by taking the standard deviation divided by the square root of the sample size. So you're going to see in this section, the only difference is when you were doing probabilities with the normal distribution, you would just do the x minus the population mean divided by the population standard deviation. In this case, we are going to take into account our sample size. All right, so over here, I'm going to get my lower z, my upper z. So I would take my x minus the mean, and I'm going to absolute reference that because I'm going to copy this formula straight down, and then divide by my standard error. So once again, the standard error is standard deviation divided by the square root of your sample size. And I get my z value, and then I'll do the same thing for here. So my upper z value, I'm just going to double click so you can see my formula, 805 minus 800 divided by my standard error. And so now to get my probabilities, I'll use the norm.s.dist, or you could look these up in a table, the z table, and that is true. And I'm going to copy this, and remember when you want the area between, which is we have an upper and a lower, you take the upper minus the lower to get your final answer. So this is kind of the big key in this section, is that you're going to divide, and you're going to see that that's going to make, I mean, notice the difference in what you're dividing. Look how huge that standard deviation was. And so that's why we take into account the sample size to make the error smaller.